All right, so today we're going to move on to the third lesson in this unit with radical functions. And we're going to look at how do we work with binomial radical expressions. Now, what the heck do we mean by a binomial? It just means two or more terms, one of which is a radical expression. So let's look at our objectives. First, how do we add and subtract radical expressions? What are the rules for that? And second, how do we multiply binomial radical expressions? All right, let's first look at the rules of how we can add or subtract radicals. We can add or subtract like radicals using the distributive property. Now, what does it mean for them to be like radicals? So two things, they have to have the same index and the same radicand. And if that's the case, then we can add or subtract them. So let's look at an example here, right? We have 5 times the cube root of x plus 3 times the cube root of x. So can we add these two together? Are they like radicals? And the answer is yes, right? They both have an index of 3 and they both have the same radicand of x. So if you were to just think of a normal expression that didn't have the radicals in here, how would we add 5x and 3x? Well, we would just add the coefficients, 5 and 3, and we'd get 8x. So we're going to do a similar thing here. We're going to add the coefficients, the numbers in front of the radical sign, and then simplify. So 5 plus 3 gives us 8 times the cube root of x. Okay, so pretty simple as long as they have the same index and the same radicand. All right, let's look at another example. 2 times the 4th root of 2 minus 4 times the 3rd root of 2. So can we add these? Are they like radicals? Well, the answer is no, right? The first one has an index of 4. The second term has an index of 3. They both have the same radicand, but they have to also have the same index. So we cannot add these together, or we can simply say cannot combine. All right, let's look at an example here. So we have 3 terms, right? 6 times the square root of 18 plus 4 times the square root of 8 minus 3 times the square root of 72. Now, are these like radicals? Well, clearly they're all square root, but they have different radicands, right? 18, 8, and 72. Okay, so before we just say no, we can't combine, let's see what happens if we were to simplify the radicals. So we're going to factor each radicand into perfect squares in this case, right? So we're going to continue to use this method of simplifying radicals in this lesson also. So 18, right, we can factor as 9 times 3, and I'm going to write the 9 as 3 squared. 8, I can factor as 4 times 2. 4 is a perfect square, so we'll write that as 2 squared. And 72, I'm going to factor as 36 times 2. 36 is a perfect square, and we can write that as 6 squared. All right, let's go ahead and simplify. So we can bring out the 3. So 3 times 6 gives us 18. We still have square root of 2. For the second term, we can bring out a 2. So 2 times 4 is 8. Still have square root of 2. And the third term, we can bring out the 6. So 6 times a negative 3 gives us a negative 18. And we still have the square root of 2. Now, notice, do we have like radicals? Yes, we do. They all are square root of 2, same index and same radicand. So let's rewrite this using the distributive property. We're going to add all the coefficients together, right? So we have a positive 18, a positive 8, and a negative 18, all times the square root of 2. Now this one's pretty easy to simplify, right? The 18 and negative 18 will cancel each other out, and we're left with 8 times the square root of 2. Okay, so there's an example where before we just say no, we can't combine them because they're not like radicals. Can we simplify the radicands so that they are like radicals and we can then add or subtract them? All right, let's try a few of these. Do these on your own paper here. 2 square root of 7 plus 3 square root of 7. All right, can we add them? Yes, they are like radicals, square root of 7. So we simply add the coefficients together. Let's try this one. 14 times the cube root of 5 minus 20 times the cube root of 5. All right, yes, they are like radicals. So we're going to combine the coefficients, 14 and negative 20. So that gives us a negative 6 cube root of 5. How about this one? So if you said no, that's correct, right? We have cube root of 3 and then cube root of 4. So we don't have the same radicands. And can we simplify the square root or cube root of 4? No, we cannot. So all we can say here is that we can't combine. Let's try one more. 5 times the square root of 2 plus 7 times the square root of 8. Now, if you said they are not like radicals, you're correct, but can we simplify square root of 8? And it turns out we can, right? We can factor 8 with perfect square of 4 times 2. So we'll rewrite 4 as 2 squared. We bring out the 2. 2 times 7 gives us 14. Now we have like radicals, and we just need to add the coefficient. So 5 plus 14 gives us 19. All right, let's try one with 3 terms, a little more tricky here. So again, they don't look like, they don't look like they are radicals or like radicals. So go ahead and simplify. So I'm just going to give you a few seconds to pause this here and see if you can work through this on your own paper. All right, here we go. So how can we simplify each of these, right? 50, 32, and 18. So 50, we can factor as 25 and 2. 25 is a perfect square. 32, we can factor as 16 times 2. 16 is a perfect square. And 18, we can factor as 9 times 2. 9 is a perfect square. So what would that look like? I know I did this really quickly here, but let's step through, right? 25 we can write as 5 squared. 16 we can write as 4 squared. 9 we can write as 3 squared. Let me get my pen here. We'll do a little annotation as we work through this. All right, so now that we've written it as perfect squares here, right, where can we simplify? So if we bring the 5 out, 5 times whatever's in front, well, there's nothing in front, so it just remains 5. We bring the 4 out, 4 times 3 gives us 12. We bring the 3 out, 3 times a negative 5 gives us a negative 15. All right, so now we have like radicals and we can combine these. A 5, a positive 12, and a negative 15. We add all those up, we get 2. 2 times the square root of 2. All right. Now we know how to add if they're like radicals. They just have to be simplified so that we do have like radicals. Otherwise, we say we can't combine. Now, how about multiplying binomial radical expressions? Now, a binomial radical expression is simply 2 or more terms, and one of those terms or more contains a radical, right? If we look at this example here, right? Here's our 2 binomials, right? The first one are these 3 plus 2 root 5, 2 terms, and one of them contains a radical. Same thing here, 2 terms, and one of them contains a radical. Right? Now, think back to your Math 2 class where you were working with quadratic functions and binomial expressions. And how did you multiply those together? You remember something called FOIL? or sometimes the box method, different names for it. But basically, we're going to multiply and distribute, right, all these terms to each other. And FOIL is just simply a way to remember all the steps that we're going to multiply. So let's use that here, okay? So FOIL stands for first, outer, inner, and then last. So the first term, right, is 3 times 2, first term in each of the binomials. That just gives us 6. The outer terms are 3 and 4 times the square root of 5. Now, remember from our second lesson, what parts can we multiply? We could multiply the coefficients together. So we're going to multiply the 3 and the 4, and then we just bring the square root of 5 along as a factor. Now let's do the inner term. Okay, so here we can multiply the 2's together. That'll give us 4 root 5. And then L stands for last. We're going to multiply these two radical expressions. So we're going to multiply the 2 and the 4 together out front as coefficients. We're going to multiply the 5 and the 5 together as our radicands. So what's that going to give us? That's going to give us 8 times the square root of 25. All right, so now we're back to adding or subtracting radical expressions, right? Do we have like radicals that we can combine? Well, we do, right? 12 root 5 and 4 root 5, we can combine those. What about this last term here? 8 times the square root of 25. Now 25, that's a perfect square. And so we can take the square root of that. That's simply going to become 5. Right? So let's go ahead and do that here, right? 5 times 8 gives us 40. So once we simplify, there's no radical left. And we can combine that with the 6 up front. So we have 6 plus 40. Now let's combine the radical terms, like 12 root 5 and 4 root 5. They're like radicals, so all we have to do is add the 12 and the 4. And we can now simplify, right? 6 plus 40 is 46. 12 plus 4 is 16 root 5. So there is our final answer, right? That we got by multiplying two radical expressions. And we're using the FOIL method, which you probably remember, or you may think, oh, this sounds familiar here. All right, let's just try a couple of extras and then we'll be done. Let's wrap this up. Not a big long lesson today. So 2 plus 4 root of 3 times 1 minus 5 root of 3. So again, let's use the FOIL. So first term, 2 and 1 gives us 2. The outer terms, 2 times negative 5 root 3 gives us negative 10 root 3. The inside terms, well, we just have 1 on the right times 4 root 3. So that just remains 4 root 3. And then let's multiply the two radical terms. So I'm going to get my pen going again here. So notice we can multiply the 4 and the 5 together, right? So we'll multiply these two, and we're going to multiply the two radicands together, the 3 and the 3. Okay. So what does that look like? 4 times negative 5 is negative 20. 3 times 3 is 9. All right, now we're back to combining like radicals. So let's simplify the last term here. 9 is a perfect square. So 3 times a negative 20 gives us a negative 60. And so now we have some integers we can combine, and we have some radical or like radicals that we can combine. So the 2, right, and the negative 60, and then we have a negative 10 root 3 and a positive 4 root 3. So let's combine those. So 2 minus 60 and negative 10 plus 4. Let's do the math. 2 minus 60 is a negative 58. And negative 10 plus 4 is a negative 6 root 3. All right, that's it. All right, let's try another one. See if you can do this from start to finish yourself. So go ahead and pause and then work out the problem and then check your result. All right, I'm not going to speak. I'm just going to show the steps here. You can check your work. right? So did you get it right? -2 minus 6 root 5. All right, one more here. Square root of 2 minus square root of 3 times square root of 2 minus square root of 3. So it's really the same binomial we're multiplying by itself. Right, so go ahead and pause it, see if you can work this through. All right, here we go. So notice, let's get the pen going again here. Square root of 2 times square root of 2, that would be square root of 4, which gives us 2. And then we're going to multiply the inside. So square root of -3 times square root of 2 gives us -6. If we multiply the outer terms, notice we're going to get the same thing. Square root of 2 times square root of -3 gives us another -6. And then the last terms, negative square root of 3 times negative square root of 3 gives us a +3. Now, square root of 3 times square root of 3 is 9, square root of 9, but that's a perfect square. That's where the 3 comes from. All right, what can we combine here? So the 3 and the 2. And so let's add the integers together. And we can combine these like radicals. They're both square root of 6. Now there's no coefficient in front, but just treat it like a 1. So our final answer is 2 and 3 gives us 5, a -1 and another -1 gives us a -2 root 6. Okay, so that's, oops, let's clear this. That's what we had for today. You know how to add and subtract like radicals, have to have the same index and the same radicand. If not, can you simplify them first and then combine like radicals? And then how do we multiply binomial radical expressions? Well, we use the FOIL method. And then we're right back to adding and subtracting radical expressions as long as they are like radicals.